Hi everyone. So let's start. I hope you can see my screen. If there is any difficulty, please let me know. Send a message on the chat or on to let me know if there is any issue. Let me start the recording which we have done. That's good. And make sure I resume recording, which I have done now. Thank you. Thanks everyone for joining RFCs We Love. This today we are focusing on some new ideas from ITF 110, which are about application and network working together. One is a sort of a new idea. Another one is been there for a while, but it's currently looking for rechartering. So we thought like it will be a good idea to cover these two topics together. So, welcome. This is our 21st meetup that we have been doing for a while. Uh, and since we went on lockdown and the new world order, this is our eighth fully virtual one. So, it's good that we have been able to continue to do that all over, during this year as well. If this is your first RFCs We Love, this has been organized by IIE-SOC, which is India Internet Engineering Society. We do a couple of events, just like RFCs We Love. We do a pre-ITF event called Connections, which we have been doing since 2017. This year, it was a post-ITF, something that we do in December, and a fully virtual one. Apart from that, this year we have started an IPv6 webinar series. I have specific slides on that, which will introduce that work. And people who have been attending these webinars and are aware would already be aware of these activities. So before we uh, before we start, let's take a quick poll, trying to get a read uh, of like who all are new today. So if just click on the poll and you will see like how many of you have attended the event before. If this is your first event, you have been here for a while, so we see a couple of them who have been attending a lot of our events. So it's good to see new folks as well as people returning. So thank you. Thanks for the information. Let's move ahead. Some news, I think ITF 110 happened in March. We had a new ITF leadership that was seated in ITF 110. So a new set of ISG members, a new ITF chair, IAB, etc. ITF 111, which was planned for San Francisco, it's in July. A decision whether it will be a hybrid meeting, hybrid in the sense maybe some people might still be able to be there in person, and the virtual rest of the world might be virtual. So a hybrid meeting or a fully online meeting, one of these options will soon be decided. In any case, we are here to help you if this is your first IETF meeting, and if you need help with understanding how to prepare for an ITF meeting. We did an RFCs We Love in July last year, completely focused on this. Here is the link. What I will do is after my talk gets over, I will put all these links in the chat window as well. And anyway, all the materials will be shared afterwards as well. So you would have all the links. So if this is your first ITF meeting and if you need help preparing, we are here to help you. Please ask. Okay, this is regarding the IPv6 webinar, which I was talking earlier about. So we have started this project. This is a multi-year project with the first phase focused on training, and then focusing on what are the impact on application conversions or security, which are related to IPv6, as well as start working with enterprises, universities, etc., in getting them ready for IPv6 deployment and migration. So we have been getting support from APNIC, and we have been working with INTC for this project. You will find the details on the IPv6 webpage of our website. The phase one was IPv6 webinar series. So we have been doing this starting from February. We have covered basic of IPv6, neighbor discovery, and now we have address planning, transition, and other topics ahead of us. So April 8th, which is next week, we have IPv6 address planning. This is a very interesting topic. So please do attend. The recordings of the past sessions are also available. So you can go through them. If you have any questions, please reach out to us. So this is going pretty well. We have been doing classes plus labs labs have been quite interesting, where we are trying the techniques hands-on, in, like, looking at Wireshark and all that's interesting stuff. So I'm sure you'll find this quite interesting if IPv6 is of interest to you. Finally, stay connected. We have a mailing list hosted at Ietf.org. It's called Ietf India Community. We have a WhatsApp group which is quite active. We are on LinkedIn and other places as well. As I said, I will post this link in the chat window once I'm done talking. So, without any further ado, let's focus on the key technical topics for today. So, today it's an ITF 110 edition. We wanted to bring in some topics that were discussed during ITF 110 and wanted to focus in especially on applications and network collaboration. So, APN stands for Application Aware Networking. This has been discussed in past ITFs as well as this ITF. It was discussed at multiple working groups, trying to get a feeling from various different working groups on what they think of this new work. Shuping will be going through that presentation, trying to explain what this work is, what it isn't, and if you have any questions while the presentation is going on, please use the Q&A feature where you can type in the question at the end, and if the time allow, I can even ask, we can also ask verbal questions, and you can raise hands and I can give you permission to speak. But we expect people to use the Q&A first, where they can type in the question, which will be much easier for Shuping as well as for our record keeping as well. The next topic is Alto. The Alto working group, which stands for Application Layer Traffic Optimization, has been there for a while, but currently they are thinking about what new work they can take as a part of their rechartering process. So again, it will be a very good idea to recap and think about what are the new work in this area that is being proposed in ITF. So let's start with the first topic, which is application aware networking. Let me give a very quick introduction to Shuping. It's been a pleasure to work with Shuping. We are a colleague at Huawei. And she is a principal IP standard representative. She's been working on IPv6 and SRv6 for a long time. She has been active in various projects in European and UK national projects and in China as well. At ITF, she is a working group secretary for Spring Working Group, which is focusing on segment routing and SRv6. She's active in BBF, CCSA as well. So let's welcome Shuping and let's move to the first technical topic. So I'll stop sharing, and Shuping, you can share your screen and start.
Yeah, sure. Thank you, Dhruv. Okay. Hello, everybody. And it's my pleasure to introduce you about the APN, Application Aware Networking. And I'm Shuping. So today I'm going to follow what, why, and how this logic to give this presentation. So first, what is APN? And APN, actually, we aim on the network layer to support the fine-grained user group, application group, service level requirements guarantee. In order to achieve this, and we will add APN attribute into the data packets and carry along with the packets and across the network to provide the application-aware network services. In order to do this, and we will develop a framework and a set of mechanisms. And so, as I said, the APN attribute is going to be encapsulated in the data packet, and it will be treated as an object in the network. And against this attribute, the network operators could apply the policies in the various nodes and the service functions along the path. And so what is very important is APN works within a limited trusted domain. And the APN attribute is tagged and removed at the edge of the network domain. So that means once the packets leaves the limited domain, the APN attribute will be removed from the packets, so it won't impact the rest of the internet. And within this domain, the network operators could provide the services on top of their various data plane using the MPLS and the SRv6, those network technologies. So what is equally important is what APN is not. So APN is not about identifying the particular applications or particular users to the network or within the network. Actually, we only focus on the policy enforcement in the network. And the network doesn't even need to know this information about the particular user applications uses. So it will also break the privacy. And so it's only about telling the network about the policies to be applied to this traffic flow. And also there are some similar works in Ietf. But APN is different from those work. First of all, the PAN-RD, and that is path-aware network. That's make the application aware of the network attributes. So that is in a different direction. APN aims to make the network aware of the application's requirements. And APN is not SPA and plus, and maybe you heard of them. So that is also the attempt in the Ietf, and that is to add the application-aware information on the transport layer. And for the APN is different. APN so APN will add the APN attribute on the network layer. And APN is different from the network tokens, which start to adding the network tokens at the host, but the APN starts from the network edge. So for example, the CPE, the device, the CPE, and from there, the APN attribute is add. And so that is different. And also we had several side meetings in Ietf, and this is one of the conclusions we achieved. That is to convey the information, application-aware information, where different layers, either the transport or application and the network layers are different technologies. And APN aims to use the network layer, the IP layer. And there are, so now why APN? There are already some use cases, and we have published those drafts in Ietf, and those drafts, if you are interested, you could have a look. And so these drafts are all collaborated with the operators. And so for this one, it's edge computing related use cases as cloud computing, cloud gaming, and augmented reality. So that is APN. Using APN, it will choose the path that can satisfy the requirements, the highly demanding requirements of those applications. And for example, that could steer the traffic along into the SRv6 path to guarantee its low latency requirements of those applications. And for this, on this draft, it states about the APN with SRv6 to support the SD-WAN. And for SD-WAN, I'm going into details later. So with APN attribute, the SRv6 path could be selected and to achieve better performance. And here, this draft is about game acceleration. So with APN attribute, it could choose the path that could satisfy the highly demanding gaming applications requirements. And here is one is about the CDN. So currently, the CDN is still not aware of different types of services or applications to be served. And with APN, that could select the right path and the resources more efficiently. And here also, this is called service aware awareness. And for these mission critical applications or services that could choose a particular path to satisfy its requirements. And so those use cases have been presented in the side meeting 108. And here is the link, so you could refer to this. And that contains all the materials presented by the operators. And now, for the SD1 use case in particular, and from here, we can see, so generally network operators can support the SLA guaranteed WAN lines and to help the enterprise to access to the cloud. And when we map the WAN line into the operator's network, there are usually multiple choices, multiple paths for you to choose. And each path has different SLA guarantee. And in the standards MEF 70, you could find there are already a list of matching items and published. So with these match items, and the edge device like CPE could steer the traffic into the corresponding WAN lines across the network operator's network, according to the user application's requirements. But still, and there is a need to communicate the user application's requirements into the network. Why? Because once the traffic goes into the operator's network, there is need to apply the various policies in the different places, that is the different nodes, different service functions along the network path. And so for example, at the head end, and we need to steer the traffic into the corresponding path to support the SLA. And at the midpoint, as we can collect the corresponding performance measurement data. And at the service function, we could execute particular policies. So, however, currently, there is still no way to request the policy to be applied to all the packets in the traffic flow and along the path on the various nodes or service functions. So possibly you could stack the various policies in a list of TRVs in the head of packet. But you can imagine that will impose a big challenge on the hardware processing and forwarding. And also, so when we do the policy-based routing, we usually use ACL via 5 tuples. But in some cases, it's very complicated to resolve those 5 tuples. And for example, when we have the tunnel encapsulation, it's very difficult to resolve the 5 tuples because the transport layer is pushed so down. And also with the IPv6 data plane, generally there will be a list of extension headers between the IPv6 standard header and the payload and the up layer. So in that case, it will become very difficult to achieve the to collect the 5 tuples with the list of extension headers inserted. And also with IPsec, it's impossible to obtain any transport layer information. So how to solve it? And here we propose to use this APN attribute and to construct it at the network edge and encapsulate it in the packets. And this this information, this attribute is treated as an object in the network. And to this, against this information, the operators could apply policies and provide services in the various places along the path. And it will also bring a lot of benefits. For example, so before we have to resolve the 5 tuples when we do the policy enforcement within the network. But now you only need to look at one field in the IP layer, in the IP packet header. So that will improve the scalability. And also it will be very flexible to do the policy enforcement. And also, so here, when we do the policy enforcement in the service function, that is the VAS. So generally, we need to first do the packet inspection to see what it is, what application it belongs to. But now, with this carried APN attribute, you only need to read it and you know what it is, and you can directly perform the policy. And also, it will help the fine granularity performance measurement. So that could be to monitor and visualize at the midpoint within the network. And also, it's not only for the underlay, but also for the overlay. And so you could find it could be easily done by using this APN attribute information, but it's not possible with any of the current existing mechanisms. And we have done some gap analysis. And if you have more to be added, please let us know. And so here, very quickly, for the DSCP, it is very short and it's not big enough to support the ever emerging new services, new applications. And here about the IPv6 flow label or MPLS entropy label. So basically, this has been standardized to be used for ECMP and link aggregation. And for the SFC service ID, there is a working group draft, but that is carried in the NSH. But the APN attribute could be carried in various data plane. Actually, it is decoupled. And for the IOM flow ID, that is used to correlate the exported data for the same flow and from multiple nodes and multiple packets. But APN could serve more purpose. And banding seed, that is bounded to the SR policy, but APN is not to bound to SRv6. And the flow spec, that is bound to MPLS, but APN is not. So, and we can see that those existing solutions are specific to a particular scenario or data plane, but APN is actually more flexible. And with the ever-emerging new services, the fine granularity service provisioning becomes very urgent. So in summary, APN aims to define a generalized attribute used for the fine-grained service provisioning within the network and on top of the various data plane. And we have presented in a few working groups, and some are suggested by the IESG, and in this Ietf, as the Roof that just mentioned. And we found that except the routing area, and for the other area, for example, the application or security or internet, they have been asking the similar questions. And here I put those frequently asked questions here. So basically, and people asked, what are the applications, or are there any applications that can benefit from APN? So here I would say any highly demanding applications that need differentiated treatment, and especially during the congestion can benefit from APN, such as the video conferencing. And in this Ietf, we also had the hackathon, application-aware GSRv6 networking. And we have it's going to be presented soon, and the paper will be published soon. But we also have another paper last year is about the demonstration of APN, and we showcased the 4 key features of APN 6 in the InfoComm 2020. And here I have gave you the reference, and so you could have a look, find more details. And how APN could help resolve the QoE. And here we would say the QoE is very complicated. It's end-to-end. And APN aims to provide ways to improve the QoE within the network. And actually APN could help the network aware of the QoE of the applications. That is very important for the operators and for their operation of the network. And then it's about who set the APN attribute and how to set and how to use it. So here, and APN is to set the attribute at the edge device, such as CPE. It's not as the host, not as the application. And how to set, so that we could have multiple ways. And we could use the n tuples defined in the MEF 70 I just presented. And we use what is already there and to map into an APN attribute and use it within the network, and to do more efficient policy enforcement, and how it could be used. So here I already presented. So basically, and this APN attribute is treated as an object. And within the network, operator could apply the services and to enforce the policies on this flow along the path. For example, at the head end to steer the traffic into the path, and at midpoint to collect the performance measurement data, or at the service functions to execute particular policies. And here we also have some other questions. And I would also like to have your opinions or comments and your help here. So whether there will be any security and privacy issues, and if we add this APN attribute within the limited operators controlled domain. And to mitigate the privacy issues, we could group the users' applications, and this is what we are doing now. And we can use an opaque value, and also we could have the classes of the policies in the network. And very quickly, so here we aim to form a working group in the RTG area. And here shows all the potential work items that we could start in the Ietf. And starting from the data plane, we could work on the encapsulation of the APN attribute in the various data plane. And first, we need to define the APN attribute. And this is a new work marked with green and yellow for the extension of the existing work. And the control plane, we need the extension of the protocols to carry the APN ID, APN attribute. And we would need architecture, the framework, and key components, and also to clarify the security privacy issues. And on top, we will support new services with the APN attribute. And currently we have an APN mailing list, Ietf mailing list, and you are very welcome to join us. Please subscribe, and you could have the subscription information here. And you could post whatever you want to say about APN, and we could have more discussion there. And so now it's about APN activities. And we have a couple of side meetings And here you could see we attract a lot of interest in Ietf. And we also host a few hackathons to demo the APN features and the performance. And also we have demos in the and paper published in Infocom this year and last year, and now is the mailing list. Here is the hackathon. And here is about the papers, Infocom papers. And here are some references you could refer to, including the drafts in Ietf. And we have the APN in the GitHub. And so you could find all the related materials of APN here. So that's it. Any questions? Thank you.
Thank you, Shupeng. Thanks for this. We have a couple of questions already in the Q&A. Let's start with the first one. The first one is from Srinivas. It's about how the APN label / concept is different from slicing. That means network slicing. Even network slice can also comes with a definition of an expected SLA. So maybe you can compare how the network slicing and the APN work relates to each other.
Oh, yes. So APN, the attribute is more about the user's requirements. And the slicing is more about the marking of the network resources. And so you could have the isolation. Either the hard slicing or soft slicing. So this is like two different concepts. One is from the service requirements. The other is from the network. Oh my, where is it? So it's finished.
Yeah.
Then,
Thanks.
yeah.
The next one I think is related to DivServe. So we have two questions, and you kind of did cover it in one of your slides. Maybe you can expand it a little bit more of comparing APN with DivServe, and also with the DSCP values which are already there, and why they are not enough for the APN use case.
Yes. So thank you for these questions. And actually, especially in the enterprise scenario and for the verticals, you could find there are very fine-grained service that different types of services that needs to be differentiated, and some for production, some for office. And so they need different treatments along the same network. And you could find that using DSCP is not enough. So that is what we got by talking with our customers.
Thank you.
That is driven by the real requirements.
Could you also say, when we say fine-grained, how fine are we giving? Can you give some more examples for people to visualize?
Oh, yes. So actually the fine-grained is not, the granularity is small, because here we are using the application group and using group. But the key idea here is, before in IP network, we only have 5 tuples. And that is the source and destination and the addresses and the port and the protocols. But now we have this service level information. And with that, we could have actually unlimited marking of our service flows. That is different.
Thank you. The next question is about MPLS network, and asking, is APN will be mapped to specific label at some point of time? So people want to visualize, how would you do this for MPLS network?
Yes, good questions. And so MPLS is one of the data plane we are going to explore in Ietf. And about the encapsulation in MPLS, there are actually multiple ways So in the existing work, we could consider using the label, or there are also some work for the MPRS extensions. And that is one topic we could explore in Ietf. If you are interested, we could work together. Yeah.
Uh, in fact, in this ITF 110, there was a common meeting between multiple working groups like PALS, MPLS, etc., where they were thinking of how to carry the metadata information in MPLS, so and a common solution so that multiple use cases like IOAM and other things can also be solved. So this work will be like something which in a coming ITF will see more focus, and I hope that APN would be able to also utilize the same mechanism. The next question is from Kanan, and he's asking about how APN attributes are encoded in packet headers. I think he asked before you showed that diagram, but maybe you can give some more examples on how you want this to be done in SRv6 or IPv6 and some other VXLAN, for instance. How do we think that these APN attributes will be encoded?
Yes. So currently in Ietf 6-man working group, we have a draft. So it's also listed here. And in this draft, encapsulation. So I didn't put it here. And in that draft, we gave an example of using IPv6 extension headers to carry the APN attribute. So either the hop-by-hop options header or destinations options header or the SRH. SRH, we could use the optional TRV or the seed. For each seed, there is argument, and we could utilize that space, and also some other places. So that is our idea. And for other data planes like MPRS I just mentioned, and some other overlay protocols like VXLAN, Ietf, there are currently some discussions in the APN mailing list. So if you are interested, please join us in the mailing list discussions. Yeah.
Okay, thank you. The next question is about, can you explain how APN will enable new services? So for instance, I think you covered it in the slides, but maybe we can go back and you can elaborate a little bit more that what are the new services where APN is being envisioned and how it will be used. For instance, maybe you can take one example from your initial slides.
Yeah. So here, and we also have the draft and the APN problem statement and use cases. So in that draft, you could find the use cases described here. I just gave one example about the measurement. So we know in Ietf, we have this IOAM and IFIT, and that could do the performance measurement per flow, and it's a in situ performance management. But they use the flow ID to differentiate, to mark the flow. But if we use the APN attribute, APN ID, we are going to achieve the finer grained performance measurement or even visualization. So that is the use case. And for the SFC, and there is also discussions in the mailing list. And the idea is on each, so first, you could use the APN attribute to steer the traffic into the corresponding SFC. And then on each VAS, you don't need to do the packet inspection. And you only need to read the APN attribute encapsulated in the IP header, and then you can directly do the policy enforcement. So that is the two examples I gave here.
Thank you. I think the next question is again focused on DSCP. So we need to, the question is why DSCP is not enough. Does that mean 64 values are not good enough? QoS realization within switches routers is limited with number of schedulers and queues as well. Are we expecting more? Do we have real need? Can we have concrete example of this amount of scalability? So I think if I understand the question well, first thing is we need to say that is it only about QoS that we are dealing? Because I think people are having a hard time differentiating between the DHCP value versus your APN attribute. So maybe you can explain that, and as well as go from the QoS point of view, what is the enhanced finer grained QoS we are talking about here?
Yes, sure. And so again, for the DSCP, that is a short value actually with no meaning. And yeah, you could say it's a classes, but as I said before, these classes is not enough for a particular, for especially for the enterprise scenarios. There are many different services that need to be differentiated, treated. And for the queues, so APN is not about differentiate in queues. You can think about it in this way. We know the queues, it has a limited capability within the device, and you only have those several classes. But now with SRv6, we could actually have so many paths, explicit paths, and each path is marked with a color. So with that, actually, it's a path level scheduling. It's not only like a particular node, the scheduling on the particular node, which is using the queues. So that is the different. And when we integrate APN and SRv6, that is, we use the APN attribute to select the path, which has the color to indicate its SRA. So that is the difference. I'm not sure I make it clear. So, yeah.
Thanks, Shuping. I think last two questions we'll answer them quickly. After that, we are over time. The last question is related to the boundary. So, how would this work in an inter-AS case? Could you elaborate on that as well, as we are saying that we are limited to one limited domain? So, what happens when we leave the domain? How does this work in an inter-AS case?
Oh, yes. So I think that is for the interoperators. And APN could work within each limited domain. We can treat it as a domain. And within this domain, you could use your own APN attribute, and you against this attribute, you could do the policy enforcement. But after the packet leaves this domain, the APN attribute will be removed. Once the packet goes into another domain, that is could be owned by another operator, and that could be there will be another APN attribute in this domain. And so with this APN attribute, this operator could perform corresponding services on top of this traffic.
Thank you, Shuping. Shuping, one more question which came in the chat. What about, can you explain what are the security issues? Like what could be the issues with looking at the APN attributes? Any security issues that you have analyzed?
Yes, so here actually that was the challenges we received in Ietf. So from us, we think there is no security issues because we only work within the limited domain. We tag the APN attribute as the network edge, and we use it within this network, and we remove it after the packet leaves. So from us, there is no security issues. If there are some issues, we could work within this network. With the current existing technologies, we could fix it. I think but we don't know what other people think. So I think probably the security issues is people have the confusion that we tag the APN attribute from the application and from the host. And that is the application itself and tag the APN attribute. And this attribute will be encapsulated in the packet and travels along the path and then goes into this network. So the APN, the applications carry this APN attribute may not be trusted by the network because it is tagged by the application. I think people probably have that confused. But we don't think within the network domain there will be any issues. But we welcome your comments and discussions in the AP mailing list. Thank you.
Thank you for answering all the questions. Thank you for a great presentation. Folks, I've put the email of Shuping on the chat. So if you have further questions or if you think there is some clarification, please reach out to her. You can also reach out to info@iisoc.in and we can always connect you with our speakers in our series. So thank you, Shuping.
Thank you.
Would you mind? Yeah, thank you. Let me share my screen now and introduce the next topic. Okay, so next we have Alto, which stands for Application Layer Traffic Optimization, and our presenter is Sabine. Sabine is a senior researcher at Nokia Bell Labs. Her research is on intent-based networking and network abstraction. She has been active in Ietf and Alto working group, as well as in IRTF and NMRG. She has been in the industry for a very, very long time. You can see, like, she has done so much. So it's really good to have Sabine today for the first time at RFC's We Love Meetup. So off to you, Sabine. I'll stop sharing. Sabine, you are on mute.
Yes, hello.
Yes, and you can even enable video if you wanted to. And your screen is visible. Go ahead.
So can you see my screen? Yes. Sorry for the video. It's too late. Let me maybe. Is it better this way? Visibility?
Is it possible to make it full screen?
I need to figure out how to do this.
It should be in the view.
Okay, yeah, in the view. Let me page display.
No, not this one. I can't see the other one. Let me see where it should be.
Yeah, I tried to figure out earlier, but
it's okay then. I think it's pretty good enough. We can start.
Okay. Let me try. Let's try. Yeah, it didn't work so well with that display. So, okay. So, hello everybody, and thank you very much for introducing me and presenting. Let me present my work. So, this is about the Ietf Alto Working Group progress and status. So I shall start with the basic Alto features and then speak about the extended Alto features that have been standardized so far or whose standardization is in progress. And this work was done upon the Recharter in 2014. And we will visit some motivating use cases for this the current charter. And I will finish with the current Recharter discussions that happened at the last Ietf. And so please note that this presentation gathers material already presented at the Ietf that was of course updated with respect to the progress of the design. And then I give this talk as an Ietf Alto contributor. So the Ietf Alto protocol, so Alto stands for Application Layer Traffic Optimization. It's a client-server protocol that is designed to guide applications in their connection decisions, where this guidance is provided with infrastructure awareness in order to moderate operator costs. And at the same time, they want to ensure at least the same quality of experience as without a guidance. So the motivating use cases to create this Alto working group was initially peer-to-peer, where in an overlay, for example, your neighbor is, okay, you have neighbors and candidate location with whom to share content, while your neighbors on the overlay, but actually are located like in very in networks that are very far away, and also in non-peering networks. So there is a waste of resources. There is also a increase of transportation cost. And then after this peer-to-peer case, the CDN use case popped up, because Alto was found as being very useful to decide where to move content, which surrogate server to select. So the Alto guidance to application is based on an abstracted operator topology information. So this exposes a subjective operator-centric view of the underlying topology and its capabilities. So it's not like the BGP looking glass that, by the way, takes a lot of time to download and sort out. This really reflects the operator preferences in terms of costs, of path costs. So Alto provides information in JSON format, so human readable information. And doing this, two above mentioned things, it hides both the complexity, but also the confidentiality of provider network information. So the base protocol was published in 2014 as RFC 7285. And upon rechartering in 2014, Alto has been extended with new features that allow a better informed decision with respect to performance metric, time, more topology insights, while reducing data exchange volume that can increase very quickly. So a new charter for the working group is currently under discussion to support emerging new use cases and further optimize the protocol. So the basic features of the base protocol are the following. So Alto offers RESTful APIs to convey provider-defined information features. So the fundamental feature here that reflects subjective, like human readable representation of the topology is the PID, which stands for Provider Defined ID. It's an identifier for a group of IP addresses. And this group of IP addresses is gathered with respect to some common characteristic. For example, they're in the same subnet, the same POP, the same AS, the same central office, or they share the same policy, whatever is arbitrarily decided by the management of the ISP that decides to gather these addresses. So this is fundamental. So a PID is a set of IP addresses in the base protocol. So the base protocol offers several information services. So we have an Alto network map, which is as I said, the partition of the internet in PIDs, and this is a must. The protocol must, I mean, the implementation must provide this. So you can decide, for example, that the internet is like 3 PIDs to make it really like exaggerated. So it's like it can be my city, my continent, and the rest of the world, for example. So with this network map, Alto builds a cost map. So a cost map is a set of end-to-end path costs among sets of source and destination PIDs. So it's provided pairwise for each source and destination pair. And we also have like a finer grain information called Alto endpoint cost map. So the end-to-end path costs are provided among sets of source and destination IP addresses, represented by Alto endpoints. So the Alto costs can abstract real values in numerical scores or ordinal ranking. So the base protocol mandates if you ever provide a cost metric, you have to provide the so-called routing cost metric. This is ISP, a provider-defined metric that is whose mode of calculation and definition is completely arbitrary to the provider. It can be based on whatever considerations, and it just reflects, it's a numerical score that reflects the operator evaluation of how much a path, an end-to-end path may cost. And this to ensure even further confidentiality, instead of making it a numerical value, you can make it an ordinal value. The basic decision that requires to have an Alto protocol is typically I have like 10 candidate connection points. Which one shall I pick? And then the ordinal cost just gives you lists you the candidate endpoint in terms of a rank, where first rank is best and last rank is the worst. So Alto also provides properties that are defined on endpoints, and implementation of the base protocol mandates that if you ever provide an endpoint property, this must be the PID property that defines, given an IP address, which PID does it belong to. So the Alto information at this stage is assumed to be not available to third party by other means. And of course, using this requires mutual trust between operators and application. So here's an example. So we suppose that we have this network map that partitions the internet into PIDs. So as I said, the Alto base protocol provides a single node topology abstractions, meaning that it provides numerical costs or ordinal costs end to end between two source and destination PIDs or two source and destination endpoints. And Alto, basic Alto provides one single metric, supports only one single metric. So here, for example, I don't know if you see my mouse. This is how a cost map looks like. So you have the meta, you define the metric, the mode of the metric, numerical or ordinal, and the cost map looks like that. Sorry, the cost map looks like that. Okay, so upon this definition, the working group is finalizing extensions that have been initiated in 2014. So while the base protocol is helping to decide where to connect, the working group is defined 6 working group documents to extend the protocol so as to provide richer information with providing multiple metrics at the same in the same transaction, introducing additional performance metric with respect to routing cost. They also want to achieve richer decisions with time-based path cost, with also alternative quality choice. They also want to provide a deeper insight in the path with a breakdown of the end-to-end scalar cost. So by exposing abstracted intermediate steps and the properties of the steps, by reducing, of course, the exchanged data volume, by allowing incremental changes, only the Alto server would only send incremental changes, would provide better filtering constraints, will also provide periodic traffic patterns. So, and another extension is about the information features. So endpoints are extended to entities and also on which properties are conveyed, and also additional services. So with Alto to support CDNI. So I'll start with a couple of better insight in some extensions. We have RFC 8189 called Multi-Cost Alto that was published in 2019. So this RFC exposes multiple cost metrics in one response with multi-cost filtering constraints. And these constraints allow a decision compromise, such as, okay, maybe maybe a better throughput with a higher cost, or maybe a lower throughput, but then the cost needs to be lower. So the extensions also provide cost calendar that help you to decide when to connect by exposing time-dependent cost values. And it also can provide repeated traffic patterns whenever this is possible, to also reduce the volume of exchanged data. And also, given that you have time-dependent cost values, you can also better plan when you will plan your Alto request, Alto request itself. So we also have the Alto performance metric. So this introduces abstractions of network delay, jitter, packet loss, hop count, bandwidth, mainly QoS metrics. This is currently under AD review. And also with these 3 extensions, we do not have any new media type introduced. And we also achieve a significant reduction of data volume. So a couple of examples with a multi-cost. So with this extension, the client can request, for example, 2 metrics at the same time, routing cost and some bandwidth capacity, which is here a fictitious metric. And I want this, the client wants this on path with either lower cost and lower bandwidth, or higher cost but then higher bandwidth. And the Alto response is provided only on path meetings the constraints. So here is how a request looks like, and here is how a response would look like. For Alto calendars, here is another example. So the extension provides an array of time-dependent cost values, and of course with the attributes that specify how you can understand, the client can understand this information. And again, this we provide an example with a fictitious metric. So here is here is a response, an example on how the response may look like. So time interval size is in terms of seconds. And we provide, so the calendar starts at this date. We provide, the calendar lasts for the next 60 seconds after the start time. And we give 4 values. And here are the values. There are other working group extensions that are significant and introduce new media types. In particular, one very important working group item, which is supported by Alto Path Vector and Alto Entity Property Map. The Alto Path Vector are currently under working group leader review, adds abstractions of some intermediate path steps. First of all, the working group was feeling that end-to-end cost was not enough. But of course, it's tricky to unveil details of the abstraction. So the path vector provides an array of so-called abstract network elements that are encoded in a so-called path vector. And on each of these ANEs, the Alto server provides properties using the property map service that is specified by the working group document on Alto entity property maps. So the ANEs can be ephemeral, meaning that once you have your response, the ANE, the ID of this ANE disappears. It's just created for the response. So the ANEs, the property can be provided together with the ANEs in a multi-part message that combines these intermediate steps and their properties. But some ANEs can have a persistent identifier, and their properties can be queried separately using the entity property map service. The entity property map service is also a fundamental extension. So it extends endpoints to entities. So IP address to PID, AS, country, abstract network element, and many other potential entities. And on these entities, it provides properties. So it also introduces information resource dependent entity domains and property types. So the entities here can be defined relatively to, like, a PID is by definition defined relatively to an information resource, which is a network map. And of course, the PID property is also depending on an information resource, which is the network map. So I will come to some examples to make things clearer. So here is Alto path vector. So who helps deciding, well, where to connect, but also in some extent how. For example, here I have this now, while the topology, the basic protocol was hiding this part, okay, the path vector, when I query a path vector between this one and this one, will give me some insight about the intermediate steps which are currently used by the routing plan. It is not obliged to give me every router that is crossed or every network element. It just decides, the server just decides to expose the one steps that are considered as significant or important to know for the application that uses the Alto client. So for example, here I query the path between this one and this one and this one and this one. So 2 paths. So here is like how the response looks like. So the response says, okay, between this one and this one, I currently go through ANE number 1, ANE number 5, 7, 2. And from this one to this one, I go via number 1, number 5, number 7, and number 4. And when the client gets this response, it does not necessarily have a clue of what these ANEs are, but it knows that the two flows share a bottleneck. And this is very important when the application wants to schedule data transmission and wants to make sure the data volume goes through without problems. So some more now on the path vector. So as I said, you can the client can query not only the path vector just to figure out whether there is a bottleneck problem, for example, but it also can query properties on these ANEs. So in this case, together with its query on the path metric, the client queries some properties. Again, in this example, these are fictitious properties. So here, maximal reservable bandwidth or persistent entity ID. And these both, so the path vector response gathers two information resources in a same response, which is a multi-part message. So first part is the cost map. Okay, so listing the abstracted network elements that the path is going through. And on this network element, it provides a second information resource that will give the properties. And I will detail these properties on the next slide. So in this case, for example, remember I have queried two properties, max reservable bandwidth and persistent entity IDs. So on this ephemeral identifier, on two of them, I can get a persistent entity ID. Why? Because the server decides that I can store this persistent ID separately, and then I can make separate specific queries for properties of this entity using the property map service. And here, so once I get this, here is an example of separate query. So sorry, there is a typo. Actually, it's not net1 and net2, it's MEC1, MEC2. Okay, so I query on these two networks, I query properties on storage capacity, for example, and CPU. And the response tells me, gives me the storage capacity and CPU capabilities in these two intermediate steps. So two other important working group extensions and Alto feature are the incremental updates using server-sent events, which is RFC 8895. So this extension pushes updates of Alto maps and costs to clients as soon as they are available. It either pushes new or full new maps or only the parts of the maps that are updated. This depends upon client request parameters. And usually a client, okay, for some reason it may want the full map, and or for some reason the server decides it will push the full map because there are two, because all the data of this map, for example, all the data of a cost map are impacted because there has been a change in the network map. But then usually the client only wants updates. So the stream to this end, it opens a stream that updates every 15 seconds until the client requests to shut down the update stream. So this is very important because the volume of Alto maps can get huge very quickly. there are examples of industrial implementation for the CDN use cases that show it quickly comes to gigabytes. So another very important extension is Alto support to CDNI. CDNI is a working group, Ietf, which stands for Content Delivery Network Interconnection, so interconnecting CDNs. And so Alto is used to support the request routing for CDNI. And this draft, this extension is socialized as such with the CDNI working group. And so it provides a protocol for the footprint and capability advertisement interface that uses Alto to support request routing, and so as to see if the downstream CDN can accept the content request. So that's it for the, sorry?
Hi, Sabine. Sabine, before we go to the recharter, could we take some questions?
Oh, yes, of course.
Yeah, thank you. If you would like to look at the questions, maybe you can stop sharing and look at the Q&A directly. It would be easier
Okay.
that way as well. Or if I can always speak the questions as well, whichever way you are comfortable.
Well, I mean, I can see the question now. So do you see it? Or maybe you would like that I hide the names, or?
No, there is no need. I think it's already visible to all the participants. All the
Okay.
Q&A are visible to the participants.
Okay, so there is a first question. Can you show examples of ISP operators publish this Alto network cost map? Are these exchanged peer-to-peer, or the operators ISP plans to publish the API endpoint publicly? So yes, I will give you pointers to different references where on deployments, on real deployments. So there is in particular a paper that was published by Benox. Benox actually is selling solutions, Alto-based solutions to CDNs. Benox is a startup from Deutsche Telekom, and they have published an extensive paper, Conext paper, that actually shows how they deploy Alto to optimize CDNs, and they mainly use BGP routing information that they fetch from routers. And so in this paper, they really detail how the experience from the deployment. There is another deployment by Telefonica, but they did not yet publish material, because they plan to go for production in the next half of this year. There is also a strong push by China Mobile. They have published a paper at a SIGCOMM workshop on their experiments. So I will go back to this use case when we'll discuss rechartering discussion. And they are making experiments on 5G network, and where Alto is not yet deployed, but more or less to show how bad they need Alto to optimize cloud gaming on their networks. Does this answer your question?
Sabine, you can go ahead. I think Jagdish can answer again if there is some more questions.
Yes, and of course you're more than welcome to contact me via email. Is there? Yes, of course. That's the point. The Alto information is not static. It's updated regularly, And if the client wants to make sure that it has fresh information, well, whenever it needs the Alto information, it can, of course, again, get the maps, but to save some resources, actually, that's where the SSE extension is very useful, because whenever the client needs information and wants to make sure it's up to date, it can query the SSE service and just to only get the increments, the incremental updates. So how is well, the Alto path vector, so how path vector is different from segment routing, I suppose. Right path identification based on link and not costs does, in this case, provide cost based on application. The Alto actually is information is not the real information, it's an abstraction because it is unveiled to third parties. So the provider will hide the confidentiality, but also it make it more simple. It's really to provide guidance. It's not to support traffic engineering, that this information is to be provided to third parties. So yes, everything is abstracted. Even the internet view is abstracted. As I said, you can make it 3 nodes, and it can be my, I don't know, my house, my country, and and the rest of the world. So it is very different because it's abstracted and it's completely subjective.
Sabine, could you give
Yes.
more example of what are the Alto clients and where is the Alto protocol actually running? Maybe that can also help answer this question a little better.
Yeah, I realize I should have elaborated more on that. So an Alto client is typically associated to an application. For example, if I have like a video download application and I will running on my device or running on an end system or even running on an intermediate end system in the network, so I will, for example, make queries, DNS queries. Where can I get this content? Of course, the CDN provider will give me some responses that are suitable for the CDN with respect to the CDN priorities. If they give me a set of responses, I assume they are equally fine for the CDN, but they are not equally fine for the network. So an Alto client, for example, can be associated to a DNS server or a DNS client, depends if it's in an end system or in the higher in the network, in the level of the DNS resolver. It can capture it can capture the DNS responses and then reorder these DNS responses with respect to Alto information. So the DNS tell me it's like a server number 123, and Alto will say, oh, well, actually it's better 321, for example. So the typically Alto client is associated to an application, either an application client or an application server. But definitely it's associated to an application who wants to figure out where to get content from, where to place content from, where to place content, how to select surrogate server, for example, how to, and we will see it later on, given the properties of the connectivity in network, in the network, how can I adapt, for example, the bit rate? So it's typically associated to clients. How to propagate. Yes, exactly. The Alto, for the moment, the Alto information is generated in majority by the ISP. But we do have examples where Alto information can also be generated from other sources. And I will provide by email or in whatever forum Drew will recommend me more information on other ways to collect Alto information. Initially, it was deemed to reflect ISP topology, to abstract them again, and also to make things easier and simpler. But now we do have other use cases where Alto information can be gathered from public data collections with the aim of mainly simplifying and providing abstracted and an abstraction and simplifications. Yes, that's a very tricky question. So how about security issues as ISPs are giving out these informations to application? Yes, indeed. There are security issues discussed in each of these drafts, the base protocol and the extensions. Of course, the ISP are very reluctant to unveil, and I mean, if you want to know the bandwidth of link between A and B, I mean, it's just no way. So this is why Alto is defining those abstractions. So for example, while I was providing this example fictitious metrics, instead of saying, since the goal is to reflect preferences, you can give a score between 1 and 10, but also some application may have specific rights, specific access rights, because there are lots of agreements between ISPs and application. And in this case, you would the protocol and extensions they propose, they allow, they support specific URLs with only access, with restricted access. And also, in addition to that, many applications are worried about their privacy, because they say, okay, somebody malicious, some man in the middle, or even maybe the operator may monitor my requests and figure out what I am doing. So all these matters are discussed in the security sections of each of the extensions, and so with a lot of recommendation on how to deal with it. And of course, since we are aware that we cannot prevent all the attacks, well, ultimately, the drafts are recommending that we install and we run specific monitoring tools to monitor the activity of requesters or possibly server, because the server, if it's corrupted by an attack, may also provide misguidance and just destroy everything.
Thank you, Sabine. Sabine, we are almost reaching our end time, so maybe you can quickly go over what are the recharter discussions.
Yeah, okay. So the rechartering discussions, there are lots of use cases that have been proposed, and so in a first step, we aim at thoroughly studying operator application-driven use cases. So the following slides are extracted from the chair slides that were presented at Ietf, the last Ietf. So here I Sorry, yeah. So the quality is kind of bad, but I will try to fix this and upload a cleaner version. This is the working group chair presentation. So we had the basic goal, and here we had all the extensions that have been proposed. And so the recharter goal, the working group feels that there are it is necessarily to achieve the goals listed in yellow to support wireless use cases. And this is strongly pushed by China Mobile and Tencent to support cloud gaming use cases, in particular to be able to adapt bitrate based on information on the network. Also, of course, we need to further progress on defining endpoints like new addresses, like cellular addresses, and also properties and cost specific to these wireless use cases. We also need to support multi-domain and operation, because in real life, Alto actually works on application. They work multi-domain. There have been substantial work running for several years now, huge data sharing among Europe and the US, and they really badly need, it's like a petabytes data exchanges. So they are really very badly needing extensions to support multi-domain with respect to discover which Alto server shall I reach out to, and also information exchange between Alto servers. Also, we need to update the Alto deployment RFC because this is really outdated, and this answers one of the online the questions on the chat. So we need to update this with more recent deployments and use cases. And last, we need to also we need to extend path vector and all these things, the previous extension, make sure they are well adapted for multi-domain use cases. And also there is a need to further work on operating the Alto server. So I will go. So here you can. I leave this for the documentation. You can see here the use cases that we are looking at, and the first clues of proposed extensions and mechanisms. Some of these extensions have already been drafted during this very charter, so we need to revive the documents and further work on them. So here you have the rate adaptation for cloud gaming, because it runs off 5G topologies, and the 5G topology, they try to sort out which QoS they can support, and they look in one by one, and so it's not very efficient. So and also it's very specific. It has a narrow view on one run, and we feel Alto could be extended to provide to be more efficient, to provide several QoS indicators in one shot. And also because you can cascade the Alto server, you can have a view that is broader than only the run that you are looking at. And of course, we need to also extend the server, the server initiated information incremental updates to support functionality towards more like PubSub, to support a better way, optimize how the client can subscribe to information updates, because on cellular network they have high dynamics. This is the multi-domain settings. So as I said, you want to know which Alto server you reach out to, how can they exchange information. You can also have, this is driven by Telefonica, because they are going to production and they are very well aware of what they miss. So of course, it's like automation, automating generation of information resource directory, aggregation of information and harmonization, because at some point the information needs to have the same common meaning if it comes from different servers. Also, to support slicing, for example, you need to have support information that combines compute information and networking information. You also need to further work on like on-demand also information computation, so that may be out of scope in the first sight of the Alto, because how the information is computed is outside scope. Alto is a transport mechanism, but still the client, basically in this automation, the client would like to have more possibilities to request specific types of data, specific properties, or specific measurement flavors. So I hope, so I'm done, but of course I will be more than happy to get back to you. And here are some references on the Alto documentation. And in the chair slides, you may find first indication about deployment experiments, Alto deployments.
Thank you, Sabine. Thanks for a great presentation. Thanks for everyone who asked questions. I think we are done. We are a little bit over. So thanks for folks for staying on. And I hope you enjoy your rest of the weekend. Thank you.
Thank you, everybody, and have a nice weekend.
Bye.